Nothing but it is a interconnections of two or more simple circuit elements. The circuit elements are resistors, inductors or capacitors. Any arrangement of electrical sources and circuit elements is called electrical network. Basically, we are using some electrical energy sources, maybe batteries or generators, some cases batteries and generators. Circuit elements, already I will clearly say resistance, inductance and capacitance. Then what is meant by electrical circuit? Electrical circuit is nothing but it is a closed path followed by an electrical current. All electrical circuits are electrical networks. Then what is the different types of electrical circuits is it's a series and a parallel circuits. Okay, in which in any kind of circuits, source is very important thing. Source is nothing but it is a device that supplies electrical energy. Example, battery, generator. Okay, then next one is what is meant by load. Load, it is utilization of electrical energy. Example, lamp, induction motors, any kind of AC as well as DC motors or special electrical machines, heater. Okay, these are utilize the electrical energy. Then network elements, any circuit elements with two terminals that can be connected to the other circuit elements. These are network elements. Node. Okay, node is nothing but it is a junction where two or more circuit elements are connected together. In this node having two types, one is minor node, another one is a major node. What is meant by minor node? Minor node is nothing but the two elements are connected together at one point, that is minor node. Okay, more than two, that means three or more than three elements are connected together at one point. Okay, that node is major node. Then what is meant by branch? Branch is a part of circuits that lies between two junction point. Here in I will give one example. Okay, that example networks I will allocate some points. Through that points 1, 2, 3, 4, 5, 6, those points are indicated as a node. Okay, suppose in the case point 2, 5 is indicated as a major node, 1 to 6 or 1 to 2 or 2 to 5, these kind of points are indicated as branch. What is mean by loop? Loop is nothing but it is any closed path of circuit is called loop. Okay, in that network terminology, 1, 2, 3, 4, 5, 6 to form one closed loop. Otherwise 1, 2, 5, 6 only form one closed loop. 2, 3, 4, 5 is connected one closed loop. Then what is meant by mesh? Mesh is nothing but most elementary form of a loop. The mesh cannot be further divided into other loops. Okay, the loop 1, 2, 3, 4, 5, 6 is not a mesh. Okay, because it encloses two loops, 1, 2, 5, 6 and another one is here 2, 3, 4, 5. So mesh is nothing but 1, 2, 5, 6 and 2, 3, 4, 5. Okay, network elements classifications. Above the network elements is based upon we are having a different classification. One is active and passive classification. Next one is a unilateral or bilateral classification. Third one is a linear and non-linear classification. Fourth one is a lumped and distributed classifications. Here active elements, active and passive elements means active elements capable of delivering power to some external devices. Passive elements, it's not capable to delivering a power, it's capable only to receiving the power. Okay, example inductor, capacitors. Okay, these are the passive elements. What is meant by bilateral and unilateral network? If a circuit characteristics behavior independent of direction of current, that network is a bilateral network. Example, resistor. Okay, unilateral network, the circuit operation behavior is depend on direction of current. Example, half wave diode rectifier. Then next type is linear network and non-linear network. Linear network, a circuit or network parameters are resistor, inductor, capacitors are always constant, independent of change in time. Okay, not only time, it also considered as voltage, temperature, current. Okay, that kind of network is a linear network. It is applicable for Ohm's law, superposition theorem. Okay, non-linear network, a circuit parameters changes their value with change in time, temperature, voltage is known as non-linear parameters. Okay, it's an example for superposition theorem and Ohm's law are not suitable for non-linear networks. Then lumped elements and distributed elements. Lumped elements size is very small, distributed elements size is very big. Lumped elements, it is a separable, distributed for analytical purpose, unable to separate. Okay, example of lumped elements are resistor, capacitor, inductor, transformer. But distribution network, transmission lines have distributed resistance, distributed inductance, distributed capacitance. Okay, those are the some basic things. Then now we are going to discuss about Kirchhoff laws. First we are going to discuss about Kirchhoff current law. The Kirchhoff current law is nothing but sum of the current entering into any node is equal to sum of the current leaving that node. Okay, the node is a nothing but junction point of two or more branches. Here the node is A, current entering is IT, current leaving is I1, I2, I3. So IT is entering point, so IT is equal to I1 plus I2 plus I3. Okay, this is an example. In this example, okay, I1, I7, I4, I2, those currents are entering the node. That value is equal to the sum of the current is leaving the node is I3, I5 and I6. So the entering current is sum of the entering current is equal to sum of the current leaving the node. That means algebraic sum of all currents meeting at a junction is equal to the 0. Next one, Kirchhoff voltage law. Algebraic sum of all branch voltages around any closed path in a circuit is always 0 at all instant of time. If any element, the current always flow from higher potential to lower potential. In this example, three resistors R1, R2, R3 is considered. The voltage drop across R1 is V1, R2 across V2, R3 across V3. So the sum of the value V is equal to supply, V is nothing but it is supply voltage, that is equal to individual voltage drop V1, V2, V3. Okay, thank you. Close.